just get started. So as you will have just seen, we are now recording today's meeting. So welcome everyone, thanks for coming along today. If I could just ask you to mute yourself if you haven't already while the presentations are happening until we get to the Q&A section. We'll crack on, and hopefully you know the format by now. We have 45 minutes to get through what has turned out to be too many topics, so we'll probably add some more on at the end of the series. But our agenda for today, if my slides would work. They appear to be sticking. There we go. Yeah, so here's what we're going to cover today. This is webinar number 3 of 3, and as I said, there may be more topics that we can add if there is still appetite for that. They've all been focused so far on reducing cost and emissions, and today's is all about alternative energy sources. This actually follows on from webinar 1, which was focused on reducing energy consumption and increasing efficiencies. And if you haven't already, I would recommend going back and watching that recording as well. You will have also seen in the invite, I mentioned this in an email yesterday, that we were going to cover efficient transport. But as I have quickly learned with these webinars, 45 minutes is not enough time to cover multiple topics. So we may come back to that at a future time if it's something that you're still interested in hearing about. And just do some quick introductions. So Opportunity North East has worked with Ricardo in the past on some research footprinting the carbon emissions for the North East in food and drink. So I'm delighted that a couple of their experts could join us today. We have Dr. Warren Hicks, who is a senior consultant in renewable energy and has an engineering background in the development of renewable energy projects, and is currently working on a hydrogen plant for Indonesia, which sounds very grand, alongside other renewable energy projects for clients at Ricardo. And we also have Dr. Samuel Hinmers, that's quite hard to say, Sam, Hinmers, also a senior consultant in heat decarbonisation, and Sam is a process engineer with a background in heat recovery systems and has been involved in a number of projects on hydrogen and CHP. And then there's me and my sustainability role at Opportunity North East, and hopefully you all know me by now, but if you need any support in that area, then please consider me your first port of call. Questions wise, you can either type them into the chat as we go, or you can hang on to them until the end, and I'm hoping that you will take advantage of having a couple of experts with us today who may be able to answer some of your queries. So with that in mind, we'll hear first from Warren, and then we'll also have a brief presentation from Sam. We'll just stop sharing my slides while the video is loaded. We had a couple of tiny hiccups with this morning. Hopefully it's all working well.
I'm presenting today on the use of solar energy for decarbonisation and cost savings within companies. My name is Warren Hicks, and I work for a company called Ricardo in their energy and environment team. Ricardo are a large international consultancy working on a wide range of consultancy work in the energy environment area, including carrying out many net zero renewable energy feasibility studies, hydrogen, solar and renewable heat. I'm lead within our solar energy team. Renewables are becoming more important both for reducing carbon footprints of companies, but also increasingly making significant cost savings. Other company drivers could include customer pressure to provide your products from most sustainable means. You may have your own net zero targets. Your industry is possibly providing pressure to get to net zero, or you see it as enabling marketing value, including demonstrating your commitment to sustainability. One of the increasing reasons for adopting solar is that it just makes financial sense when the cost of electricity has risen so much. There are a number of ways in which a company could look to become net zero for electricity. In Scotland, the carbon in electricity generation has come very close to zero. Therefore, the first option, waiting for electricity to become net zero, is a definite option. However, the cost of electricity could be in excess of 30p per kilowatt hour. Further options can be to contract with the DNO. This would not lead to cost savings, though. A company can contract with an independent supplier through a sleeving arrangement. This will carry distribution and transmission charges, so this method will be a little cheaper, but probably not dramatically so. An alternative would be to find a developer to build a project near to the site, typically within 3 kilometres. This can lead to significantly lower cost of electricity, but will require more effort. The final method is to develop on-site renewable energy generation adjacent to the site, or renewable energy adjacent to the site. This could be either on land or buildings on the site, or alternatively there may be fields nearby that are not being used. Cost could be as low as 7p per kilowatt hour to 15p per kilowatt hour for on-site renewable energy, with payback periods between 3 years and 6 years. We'll talk about solar today, but it should be noted that wind energy is also an option. A typical solar system consists of 2 main components: modules which produce DC electricity, and an inverter which converts DC electricity into AC electricity. Electricity generated by this method will displace the grid electricity otherwise used. If all electricity is not being used, then this typically gets exported to the grid. The utility will give you a fee for electricity exported, with most utilities offering a smart export guarantee of around 5p per kilowatt hour. It is, though, worth shopping around for the best deal for the smart export guarantee. Good quality modules should be sought where possible. PV Tech produce a gradient of technology suppliers for modules. It's recommended that this is consulted. Common inverter manufacturers include German manufacturers Fronius and SME, FEMA, who brought ABB, and Power Electronics, who mainly manufactures central inverters. The current market is largely dominated by monocrystalline modules. These tend to come in 2 main sizes, with rooftop modules being around 400 watt peak and 1.7 meter by 1.1 meter, with larger modules used for ground mounted systems, which are tending towards 600 watt peak modules. Things to look out for when discussing modules would be the efficiency of the modules, with the modern solar modules being around 21% to 23% in efficiency. Most modules now have a positive tolerance, which means that if they're stated as 400 watt peak modules, they will go up to 400 watt peak plus the positive tolerance, which is typically around 3%. This means that by buying them, you will get at least the 400 watt peak at peak conditions. So it is also worth looking at the amount of annual degradation that the modules will incur. Typically look at modules with no greater than 1.5% initial degradation, and then yearly figures of around 0.4 to 0.6%. Guarantees on modules should be 12 years on components and 20 to 25 years on performance. There's a number of different application areas. On commercial rooftop is becoming increasingly attractive, particularly with the cost of grid, provided electricity going up by so much. With most new contracts that we are seeing at least 30p per kilowatt hour, or very often considerably more. 4 to 7 year paybacks can be achieved without subsidies, and then modules will typically be around the 400 watt mark. Carport solar is becoming increasingly popular, with a number of companies looking at solar carports. The main advantage of carport solar is that it can be used on space that would otherwise not be able to be used. It should be noted that France mandated that any new solar car parks, or new car parks of a certain size, will require the installation of solar carports to be installed. There may be a small amount of space that the foundations will take up, and this may lead to some car parking spots being lost. This should be factored in. Project costs are likely to be between £900 per kilowatt and £1,400 per kilowatt. And typically use 400 watt modules, as these are easy to handle. Solar carports are a good combination with electric charging points. Ground mount solar is typically the cheapest form of solar. These are modules on fixed frameworks typically, although many countries also use tracking system, which is where the solar modules are moved to track the sun. Costs are likely to be between £500 per kilowatt to £800 per kilowatt, with large systems in excess of 500 kilowatts likely to trigger concern from utilities, and therefore grid studies would be required. Floating solar is also an option. In some countries, particularly those that have limited land, there is a move towards using floating solar on reservoirs. In the UK, there's two that I know of. One is in Lancashire and owned by United Utilities, and another is in London and owned by Thames Water. A number of water utilities are actively investigating the use of solar on reservoirs. Module sizes can be in excess of 500 watt peak, with string inverters typically used. There's likely to be a mismatch between the energy generated by the solar system and the energy required by the building. Most of our studies with clients have shown that with solar only it typically makes most commercial sense to size for 30% to 50% of the overall energy use on the site. Adding wind can make a big difference with regard to the amount of renewable energy that can be used on site, as it complements solar nicely, with wind being more abundant in winter and available overnight, and solar being more abundant in the summer for longer periods. Other ways of increasing the amount of solar that can be used on site is by coupling with electric batteries or diverting to water and boilers. There's also the potential to store heat in heat batteries, which use phase change materials. Another method would be to divert the energy for use in heat pumps. By providing the electricity through renewable energy by wind and solar, it's possible to satisfy a significant amount of the energy that's used on site, potentially 70 to 80% if both wind and solar are used. However, if further electricity is required or is a need for larger renewables than those that can be used, that can be fitted on site, then there are two further methods that can be considered, as mentioned earlier. These are sleeving arrangements, which incur network charges for transmission electricity, or private wire PPA, where the company would work with the developer to provide electricity directly to the site without using the grid's connection. 15-year to 25-year contracts are common with these sort of arrangements. Ricardo can offer services to assess your sites and come up with an optimized solution, both in terms of the cost but also the carbon savings. Typical study would be to assess the existing electricity and heat use on site, identify opportunities for renewables and the likely costs, carry out energy generation and energy use study, and provide a fully costed optimal route to carbon and monetary savings on the site. Thank you everyone, and I look forward to some good questions.
Thank you very much for that, Warren. And if you have any questions for Warren, just hold them for now. And I will note any that come into the chat, and we'll now hear from Sam.
Hello, my name is Sam. I'm going to talk about other options for decarbonising, particularly focused on heat, and talk about opportunities with CHP. CHP, otherwise known as combined heat and power, has been a really important technology for the transition to net zero, and it's delivered emission savings for many years. And that's because it has a really high primary energy efficiency. There are a number of different types of CHP, and many you may have encountered, such as gas engines or gas turbines, but there are new forms such as fuel cells which are beginning to come onto the market. Now, the process is very simple. You have a fuel such as natural gas, which is burned to generate heat. And that heat is converted to work, either in the form of electrical power generation or directly driving compressors. But there may still be, or there is still useful heat in the exhaust, and that can be used to produce hot water or steam. And so you get this high efficiency because you're able to extract energy almost twice from the fuel effectively. It's particularly relevant for food and drink because it's so good at generating hot water and steam. And with energy prices as they are, CHP systems have payback times as low as 2 years. And your CHP can be configured depending on the site's requirements, so it can either be heat-led or power-led, or both if required. And if sites have complex heating systems, it can be integrated within that, or if you have chilling requirements rather than heating requirements, the heat can be used to drive an absorption chiller. And there's an attractive incentive to good quality CHP, such as the CHP Quality Assurance Programme, and you're able to export your heat to the grid to also generate revenue. But as the electricity grid continues to decarbonise, with more renewables coming online, we're seeing that the emissions abatement from CHP is beginning to reduce. So there's a question about the role of CHP into the future. But actually, it's a key technology, and that high primary energy efficiency means that it'll be key going ahead, and there are a number of options as well to extend the lifetime of installed assets. So bioenergy is a really key option for decarbonising, particularly in the food and drink sector. We're currently waiting for the government to publish its bioenergy strategy, but when it does, I can anticipate that this will outline that bioenergy should be driven towards the harder to abate sectors, such as sustainable aviation fuel or the heavy industry. However, sites that produce their own biomass or biogenic waste will find now that because of current energy prices, making use of that biomass or bioenergy on site is beginning to pay off. And it also has the benefit that it offers rapid decarbonisation. So, for example, spent grain, if that's utilised on site, because it's renewable and it's grown, you're able to massively decarbonise. And into the medium term and long term, we're going to see carbon capture becoming a key technology, and that will be introduced to be paired with bioenergy in the form of BECCS, which is bioenergy carbon capture and storage. And that's a key technology that's been outlined by IPCC that's required to get to net zero because it has the potential to provide negative emissions. So that works because you grow your biomass, you extract what you need in your process, and that waste is that energy from that is utilised, but the carbonaceous material, when it's burnt and you have your CO2, that CO2 is stored. So effectively you capture it from the atmosphere and then you're able to trap it. And this will be incentivised either by the government directly, or there'll be carbon credits. And in the medium term, you'll see that you'll be able to utilise the carbon as a green carbon dioxide source that can be used in the food and drink sector. So that will be a key technology going forward and something to look out for. Hydrogen is also another important fuel switching option, and it's currently in the news a lot, particularly about how it's going to be used for heating. But I can say with some confidence that it's going to be key in decarbonising industries, particularly in the food and drink sector, particularly as they're in the locale of the ACON project, which is going to be producing low carbon hydrogen. And yeah, the ACON project is going to be in North East Scotland, which means it's going to be nearby and worth utilising. But it's also going to be a site where you can store that carbon that's captured from, for example, the BECCS technology. And this is a really good idea and a sensible thing to do because you're going to have very clear Scope 1 and Scope 2 emissions. And this is going to help you decarbonise very rapidly. Now, hydrogen is really important and good because it provides flexibility for the energy user, as well as some form of energy security, because there's going to be challenges in the years ahead around electrical grid capacity, particularly in parts of Scotland where there can be a lot of renewable energy being generated and being exported to places like Northern England, or even as far down as London. And hydrogen is really important for distributed sites. So there isn't really a focus on these sites in the industrial strategies from the government, but you can see that actually hydrogen is going to be key to decarbonising those, particularly those in locale of the ACON project. It's a really good opportunity to decarbonise CHP. So many existing systems can either run with blends now of hydrogen or be retrofit from the blends. And some systems can have burners switched or components switched to run a full hydrogen now to extend the life of those assets that you have to get maximum fiscal benefit. And looking forward, it's very worth considering buying things like CHP that's hydrogen ready. So there's a number of technologies that are hydrogen ready, engines, burners for direct firing applications, or boilers. And with CHP in particular, you can purchase these now, get that payback time in the first couple of years, and then as part of the service schedule, convert the engine to run on 100% hydrogen and decarbonise when that's available. And here I've shown a couple of examples of some Rolls-Royce MTU engines that can run on 100% hydrogen. So just to summarise really, CHP is a really important technology. It's worth considering now into the future because there's that really quick return on investment, and it can help you transition to net zero. So you can have it in your pathway, paying it back, and then transitioning to hydrogen when it's available. And hydrogen is going to be really important in North East Scotland because of the ACON project being so nearby. And it's also worth considering bioenergy as well if you have biogenic waste or biomass that you produce on site, because that is going to be a really good source of decarbonisation, and it will reduce your energy bills with the prospect of negative emissions in the future. So the northeast of Scotland is really well placed to transition because there's going to be a number of options. It's worth considering these, and you'll be able to decarbonise at a rate that's in line with your organisation or the sectoral ambitions, achieving targets as necessary. So could be decarbonising as soon as 2030 if that's required. But to have a no regrets way forward to ensure that your decarbonisation is successful, it's worth having an understanding of policy, technology, and the economic landscape. And that's where Ricardo can help. It's worth talking to us. That's where we place ourselves. And our work pays for itself as we're experts in engines and in efficiency. So thank you very much for listening.
Thank you very much for that, Sam. So we can get onto some questions, and there's been a few in the chat already. We also have, or had, Mahmood was on the call and I don't see his, oh no, sorry, I had you covered up there, Mahmood. Nice to have you with us. Mahmood's also from Ricardo and can perhaps join the conversation if necessary. And we also have Ben Howkins from Rolls-Royce, who you heard Sam mention there, who were a client of, or perhaps are a client of Ricardo's, who's, I guess, a real life case study with us today and may also be able to chip in if necessary. So the first question was really for you, Warren, that Lewis had typed into the chat there, and it was off the back of something I was thinking about myself around, is there a big difference in solar panels supplied by different companies? And some of the conversations I've had have with businesses where they've shared quotes that have been wildly different. So I guess there's a question around how do I know about what I'm getting, and is it value for money in terms of the capital spend, and a supplementary question that he's then added on around what actions can we take to enhance the lifespan of our solar panels as well?
Right, okay, I'll take those. So in terms of solar modules, there shouldn't be that much of a difference between different manufacturers. PV Tech sort of give module ratings based on sort of how solvent the company is, that sort of thing. You probably look into get modules from companies that have been around for a while. We did have quite a big turnover of companies back in the early 2010s when they came in, set themselves up, and then because of withdrawal of subsidies and stuff like that, quite a lot of them went out of business. So typically the actual wafers themselves tend to be made by about 2 or 3 different factories dotted around the world, and then assembled into the modules themselves. So Tedlar background, glass covering, metal framing, that sort of thing. So the actual energy generation things tend to be fairly similar. As mentioned, I definitely look for modules that have got good guarantees. You can get warranties of 12 years, but the modules will actually last a lot longer than that. Some investors are looking at project lifetimes between about 30 and 40 years. The only thing you need to be wary of there is that there is degradation on the modules, which is quite low, but it's a year-on-year thing. Typical good manufacturers would be Longi, Trina, JA Solar, and various others. But yeah, I definitely recommend modules with at least a 12-year guarantee on parts. So that's the warranty as opposed to the lifetime, and also up to 25 years on power. So power rating should be no less than 80% up to 25 years. So those are the things that you should be looking for. Inverters will probably need to be changed at least once if you're running them for 30 years, because the lifetime of inverters is about 15 years. In terms of looking after your modules, get them cleaned regularly, particularly if you're in areas where there's lots of birds, and are likely to be at least once a year for cleaning. I think that's the main way of looking after the modules. If you get dirt on them and you're not cleaning them, you get hot spots on the modules, which lead to sort of degradation of the wafers, which leads to overall degradation of the performance. So I think that's answered all the questions, I think
so. Thank you for that. That's really helpful. And I also noted a question from Gareth, which you have popped an answer into, Sam, but I wondered if there was any case studies that you were able to share a little bit more detail on, or kind of stories and abilities in particular that have had some success with this technology.
Mahmood might be able to share better on this, but Mahmood, can you think of any good examples of distilleries using CHP?
Good morning first, and my name is Mahmood. I'm a technical director within Ricardo, but also CHP policy advisor to the UK government, and I've been dealing with that for about 30 years. The answer is yes. We'll try to find something in public domain to share with yourself. I run the CHP care program. That means all CHP schemes in the country comes through me, through my team. So we certify them. So yes, if there's something in the country, we will have something to share with yourself. But it has to be in public domain, so I can't share something that's not available. To answer that question, yes, there are. Where's heat required? Electricity is not the bigger issue. If you have a small amount of electricity and you still require a lot of heat, it's always been the case. First choice is actually to consider a high efficient system, which is CHP. in all sizes. They come from 50 kilowatt to 1800 megawatt in the country. So they vary in technologies, they vary in sizes, vary in application. We call it a flexible solution. But Sam mentioned this issue about decarbonization, and then when do you install CHP? If you're installing gas-fired CHP now, then you could recover the investment within 2 to 3 years, because the energy market is very attractive to CHP installations. Then you worry about, how do I decarbonize in the future? CHP can provide energy efficiency and cost saving. And if it pays itself for 2 to 3 years, a lot of people considering CHP now as gas-fired, not biogas, not biomass. It's just a quick win to be able to meet the challenges in the energy market. At the same time, they consider hydrogen ready. So when hydrogen hub become available, or hydrogen available to yourself, if you are considering to have CHP, make sure that is hydrogen ready. And on that basis, win-win scenario. You install it now, it pays for itself quickly. And then after that, you'll have a technology, when the hydrogen become available to you, then you'll be able to switch to hydrogen. I am working with the government on policy development in terms of what the future is going to look like. And we're talking about 2025, 2030 and beyond in terms of what would be the alternative solutions in the country for CHP. They haven't write off CHP. They to see CHP is the main technology of being efficient, regardless of the fuel you burn. So if you do have, somebody said about heat lead or electricity lead, that's a technical terminology we use. Electricity lead, that means you just size it to deliver electricity you require without having to export. If you have heat lead, you size it to your heat load, and if you have a surplus electricity, you could export it. And the market now for electricity prices is also attractive. So on that basis, that you need somebody who understand that, to be able to evaluate all options. And we are working with food and drink manufacturers now as we speak, looking to options. So CHP, yes, some people, they say don't touch it if it's gas fired. I would say that's a mistake. You deal with it quickly. It pays for itself, but make sure it's flexible. And about the example, we'll find one in the public domain to be able to share it with yourself. So hopefully that will be, response to your questions later on.
That's great. Thank you very much.
That's really helpful, Mohammed. We will add that to the follow-up email. And actually, you may have also answered Louise's question in the process there. Her question was around heat and power lead, and can you explain this a little bit more? Because
let me pick this issue about heating and cooling.
Yeah,
there's something we call cogeneration, which is heat and electricity, or the other one is trigeneration, which is give you heat and electricity and cooling. So if you have surplus heat, instead of throwing it away, you have an absorption chiller. A lot of sites there now, they don't really require heating, but they require cooling. So in the same times, they require electricity. So they generate electricity and they use the heat for cooling using absorption chillers. So there's many options available but you just have to make sure that you look into the heat load, the cooling load, the duration of these sort of energy demands, and the electricity requirement in there. Because when you start with using absorption chiller, you reduce your electricity demand, because there's no longer you require for cooling. So that has to be balanced before you size it, because CHP technology is not cheap, but it does pay for itself. So yes, you could use it for heating, yes, you could use it for cooling, or you could, as I said, the surplus electricity you could export or use it on site.
Okay. Louise, does that answer your question? Yes, got a thumbs up there. Good.
Excellent.
There was another question down in the chat there from Paul at Strachan's around government subsidies, which Warren has answered. I would also add to that if you fall into the SME category, there are, I think the fund may be closed for the year, but will likely reopen again in April. The Scottish Government via Business Energy Scotland is now, will provide 0% loans up to £100,000. For the installation of solar. So I've worked with quite a few businesses that have taken advantage of that. It's kind of a no-brainer now when you sort of see the payback times. And the only thing I would add to that is that given the interest in switching to renewables of late, their lead times are a lot longer than they used to be. So it's worth getting in touch with them even now if that's something that you're looking to do later in the year, and I'll drop that into the follow-up as well. Any other questions? Anyone else got anything for the experts on the call today? Or even anyone who wants to try out Ben for a little bit of experience on Rolls-Royce's journey with CHP.
I think for myself, Sharon, I'm interested in the CHP side of things from the use and obviously the distillery. Just to get more understanding of how it's used. We obviously looking at heat supply and also cooling. The electricity supply probably a little less. So, I understand what we were saying there earlier, but to get a good example of that would be very good. But also, it's it's a bit of a daft question, I suppose. But the size of these things, are they as big as they look on the diagrams? Sorry, that's a really strange question, but
It's not a strange question at all. It's like all these things have to be considered. So yeah.
Let me deal with that. They are as small as your boiler in your house, and it could be as big as the biggest power station in the country. So Sam used some sort of large engines in this case, but you could have a micro turbine, small. So there's something that's called micro CHP, which is a Stirling engine. So it's 1 kilowatt. So if campers or boating, you could actually have, the old technology, which is uses 1 kilowatt or 800 kilowatts. So it's 1 kilowatt or 800 watts. That's the smallest possible. Distilleries, they do require steam, I understand, and they require heat continuously. And CHP loves continuous heat load because that will pay for itself quicker. The more utilized, the quicker the payback period. So it's really understanding the grade of steam you require, and then you select the technology accordingly. Yeah, I mean, I asked one of my team members in there to work out from our database what we have, and he just gave me a couple of examples about 3 megawatt CHP units used in distilleries. And there's another one that's about 5 megawatt. There are reasonable big machines. But it depends about your demand. So I'm saying I don't answer that question. Say, well, I'm a small operator. Is a CHP suitable for me? As long as your require heating and cooling is suitable for you. It's just a matter of making sure you do your assumptions correctly and size it correctly, and then it will pay for itself. We certify 1,400 CHP installations in the country every year, and a lot of them in the food and drink industry. Some of them providing cooling, some of them providing heating and cooling, and some of them providing heating. So yes, there's a mix of all.
That's great. Thank you very much again.
Yeah.
Thank you. There's another couple of questions in the chat. Liam has asked around subsidies for renewable energy. Says, we can see that hydrogen plants are prominent in other countries. Are there any statistics or reports surrounding the UK's activities within the renewable energy market and what the future looks like for the UK in hosting renewable energy manufacturers? That sounds like something you might be able to respond to, Warren, maybe?
Yeah, so as far as I'm aware, and I'm not sure what the Scottish situation is, certainly subsidies, things like feed-in tariffs were withdrawn in 2021. I think it's just things like interest-free loans, as Shona mentioned, that can help out on that side of things. In terms of hydrogen, there's a lot of development hydrogen in the UK at the moment. Generally tending to focus around hydrogen hubs. So there's about 9 or 10 hydrogen hubs that have been defined around the country. That is sort of production of hydrogen. Teesside is one example. There's one on the northwest coast as well. And also, I think, as mentioned, the Acorn project, which is also doing that. It seems that the way people are looking at hydrogen at the moment is that it'll be large, sort of centralized, and then sort of tankered out rather than sort of decentralized at the moment. That might follow the electricity sort of way that it does actually start to become decentralized in a few years' time. In terms of the renewable energy market, we're not very good at manufacturing stuff. They probably heard mention of the gigavolt battery factory that was going to be set up. It looks like it's not going to go ahead anymore. We do have companies like SD Wind, who's a small manufacturer of wind turbines. So if you're looking at something between about 6 kilowatt and 15 kilowatt, then they're definitely worth a look at if you're looking to buy locally. Again, there are manufacturers setting up from overseas in the UK, particularly around blade manufacture, particularly for offshore wind and stuff like that. Yeah, solar tends to be dominated by Chinese manufacturers, at least for modules. Inverters, you can get European manufacturers generally tend not to be too much in the UK, unfortunately. So yeah, that's my best answer to that.
Thank you for that. This will probably be our last question of the day from Lewis. Perhaps one for you, Sam, around excess heat as a bakery. Obviously, that is always going to be a challenge. And could this be used as part of the CHP process?
I think that can be more focused on your use rather than your delivery, so that there should be opportunities around efficiency and reusing it. Might be you can use it, for example, to drive a heat pump to get a higher temperature lift and still have a good COP. So it's definitely worth considering. It might just be that you can reintegrate it into the process as well. I guess it depends on the scale of the ovens and how the heat is delivered. But often you can, if you reuse it in where it's coming from to preheat and whatnot, that's the cheapest and the best way to do it. But case by case, of course.
Let me just add one thing.
Yeah.
It depends about the grade of heat. There's an organic Rankine cycle. It's not really CHP, it's energy recovery. So you could take that heat and put it through an engine, and that will generate electricity for you. CHP has to have two elements, electricity and heat, utilized on site or utilized by other third parties to call it CHP. But if you have a waste heat or excess heat, it depends about the grade. If it's about 100, 120 degrees C, then you might be able to consider organic Rankine cycle. And they come as small as 25 kilowatt to hundreds of kilowatts, or even in sort of megawatt sizes. So that's another alternative for you. In addition to what Sam was referring to, you could upgrade it by using a heat pump to be able to displace heat in the first place. You're using a boiler to generate that heat. So you could be able to reduce that demand on the boiler by using a heat pump to upgrade that heat to the same temperature required for the processes. Yeah. So there's many options available. If you have waste heat, a lot of it, and you're throwing it away, then ORC or organic Rankine cycle could be an option for you.
Excellent, thank you. My mind is suitably blown. And we finished bang on time, which I love. I just would love to thank our contributors today. Thank you, Warren. Thank you, Sam. And thank you, Mahmoud, for joining us for the Q&A as well. Loved everybody's questions, and I hope you got some value from this. We'll follow up as usual with any of the resources that were mentioned in the call. And we'll also be sending out a survey just to get your feedback on what you thought of today's session, and also what you might want to hear about in future sessions as well. It really helps us to plan so that we are serving you as much as possible. So thank you, everyone. Have a great rest of your day.
Thank you very much.
Thank you.
Thank you all. Cheers.
Bye.
Yeah.
Cheers. Thanks, everyone.
Thank you.
Thank you.
Yeah.